Right, this third question. This is still June 2012. This third question is definitely integration because you see it there and there. I'm still deciding whether it includes this topic here called binomial expansion. And again, at this moment in time, you've not learned binomial expansion. So I'm going to treat this like it's not a binomial expansion question. So the very first question is you've got something minus 1 squared, so you've got a bracket squared. So the quick way to square a bracket is essentially, I'm going to call that y instead. So y minus 1 squared. So the quick way to expand a bracket is just y squared, or square the first, double the product. So minus 1 times y is minus y, double it, and then square the last. So this is a quick way to do it. So again, square the first, double the product inside bracket, and square the last. Now we're not doing y though, we're doing x to the 3 over 2. So in this case, all we're doing is x 3 over 2 all squared. So if you remember back to indices, you're just going to times these two powers out. So if you times the two powers out, you actually get 3, or to the power 3. So yeah, replace that y, and you got 3 over 2, and there you have it. There's your expansion. So you got 2 marks there. The next part is hence integrate that bracket. This is the very important word here, hence. So the moment it uses hence, you're actually using something from the previous part. Now, what are we using from the previous part? We are using this thing right here. So we're not going to integrate this bracket squared, we're going to integrate this equation right here. So that is your part B. So, sorry, that's your answer for A and the start of part B. So we'll come back to that when we mark it. So integration, remember, integration starts with an I, so we're increasing the power. Power. Oh, what happened there? Get rid of that. So yeah, we're going to increase the power. So again, increase the power by 1, divide by the new power. Increase the power by 1, plus 1, plus 1. There you are. And divide by new power. So this is a bit tricky. You can divide by 5 over 2, but what happens to the 2 is it actually comes up to the top. So we can just say it's, I've written it badly. I'll rewrite again. So I'll put a fraction in front. So minus 2x 5 over 2. Now when you divide by a fraction, remember you can also flip or times it by the flipped fraction. So instead of dividing by 5 over 2, I'm going to times by 2 over 5. So that's where I've got this bit here. In fact, I'll write it here so it makes sense a bit later on. So we can do that instead. And then integrate x, that's just become 1. And don't forget the plus c. So we haven't got limits here and here. So this is indefinite integration. So we need that plus c. So that's pretty much it. You can tidy it up a bit. So you can say that's over 4. You can't tidy this one. You can tidy this one though. So it's 4x 5 over 2 over 5 and plus x plus c. So that's your answer there. Again, by the time you get to exams, you really need to get differentiating and integrating down like it's natural to you. So you need to be able to integrate it that fast, essentially. So again, just increase power by 1, divide by a new power. You are going to be slow at it at first. It's a bit like learning anything. You've just got to keep doing it until it just becomes natural. Very last question is actually definite integration now. So again, this is my answer for B, but it's also the start of my question for C, because I've already integrated it. I don't need the plus C now, so I'll ignore that. And my limits, I'm going to substitute into it as 1 and 4. So you want to substitute your upper limit in first. So you want to do 4 squared over 4, not 4 squared, 4 to the power 4 over 4. That's a lot of 4s. Minus 4 times 4 to the power 5 over 2 divided by 5. plus 4. So that would be your one of your values. So I call that the upper value. So you want to minus your substitution of your lower limit. So that'll give you a lower value. So it'll be 1 to the power of 4, which is just 1. And again, it will just be 4 times 1 to the power of 502, which would just give you 1 again. And plus 1. So there you are. You don't want to simplify these fractions yet, because it might be the case that you can cancel some bits out. So for this first bit, I am going to do 4 to the power of 4 first. So 4 to the power of 4 is 5, no, 2, 5, 6 over 4. And again, I'm not going to simplify anything yet. 4 to the power of 5 over 2 though, I do need to calculate 4. 5 divided by 2. So that should give you 32. So 4 times 32 over 5, and then plus 4. So that's my upper value minus my lower value. Again, I'm not going to simplify anything because the fractions might cancel out on this side here. So it's going to be 4 over 5 and plus 1. So I will cancel all the things actually. So I'm going to minus a quarter. So that's going to be, in fact, let's just double check. No, in fact, yeah, you've got to pick and choose. I was about to do 256 minus 1, but actually that divides by 4 quite nicely. So 256 divided by 4 gives you 64, so I will keep it at 64. This one I will work out 32 times 4, and I'll divide it by 5. Alright, when I do this, so that times out, this top bit times out to be 158, divided by 5, it doesn't give me a nice number, so I'll keep it as a fraction. I'm going to do 4 minus 1 now. So 4 minus 1, it gives me 3. I've still got to minus a quarter, and I've still got to, because it's double negatives, I've got plus 4 over 5. So what I'm going to do is I'm going to combine these two together. So I'll do 128 plus 4. That gives me 132. That won't divide by 5 actually. So if I divide that by 5, it will give me, this bit will give me 26.4. So it's not a nice number still. I thought it would be a nice number, but it's not. You've got your calculators anyway, so you could just do all of that in your calculators really. I'm going to do it all in my calculator now. So 64 minus 26.4 plus 3 minus a quarter, so 0.25. My answer is 40.35. I think that's the last part. So yeah, it is the last part. So let me underline that so I can come back to it. Pick red this time. So let's go mark it. So question 3, the very first thing we get is wow, lost my mouse. There it is. So we've got x cubed box. So there we are. Remember, I started B with my answer from A. So we've got x cubed here. Brilliant. We've got minus 2x 3 over 2, minus 2x 3 over 2. Brilliant. And we've got plus 1. We've got plus 1 there. So what we normally get marks for, I've got the answer, so I'll get the answer mark. The method mark would be probably for this bit here. So this part of the expansion. So what I did here, in effect, with this bit here would give me my method mark. So next part is part B. So we're going to integrate this bit here. So it should be x4 over 4. Let's just check marking. So where is it? Because normally it would be a mark per term, but they're not giving it mark per term. So we're going to have to just take it bit by bit. So we get 1 mark for this part here. So x4, we got x4, we got 2 over 2 over 5. That's right, 5 over 2. So that would give us that. So let's just double check. 4 divided by 5 will give us 0.8. So there we are, we got 0.8 there. that bit's correct. Or I'll mark it down here. So that bit's good. Nope, wrong one. Mark it here. That bit's good. That bit is good. Plus x plus c. So plus x plus c. There we are. Again, I'm a bit confused where these marks are. I think the marks would be for just each term, really. So one mark for those two, one mark for those two. And then you've got the equivalent of making it into a fraction. Oh, sorry, decimals. I've not made it into decimals, so I would get the last mark here. You can make it into decimals, just because you need practice with core 1 and they use fractions in core 1. I'll probably stick with fractions. It doesn't particularly matter, to be honest. Part C then, you've now got limits. So substitute 4 in and substitute 1 in, you get 1 mark. So this here is your method mark. Next point is just working it out, and you get the last mark for the answer. So it should be, ooh, I actually messed up. So I got 40.35. It should have been 41.195. Let me just double check where I went wrong. Where did I go wrong? It's probably up here somewhere. Let's see. Alright, I'm going to plug all of this into the calculator instead of working it out by hand. So we got 4 to the power of 4 divided by 4 minus 4 times 4 to the power of, what is it, 5 over 2? 5 over 2. And that's all over 5. We want plus 4. That gives me an upper value of 42.4. And then we've got a quarter, which is 0.25, minus 4 times 1, so that's 4 over 5, and that's plus 1. So we got, for my lower value, 0.45. So if we do that minus that, so 42.4 minus that, we get 41.95. So yeah, there's the answer there. Yeah, I messed up somewhere. I'm trying to figure out where. Where is it? It's somewhere. Where would it be? Let's see. 4 to the power 4. It's 56 divided by 4. So that's definitely good. 4 to the power of 5 over 2. Yeah, I messed up there, I think. Yeah, it's this bit. Where is it? Where is it? Where is it? Can't use the mouse. There it is. Yeah, I messed up on this power bit. I must have typed it in wrong. I think I typed in 3 over 2. So that value there should have been, or this one here should have been 515 times by 4. That should be 2,480. So yeah, I messed up here. I typed in 3 over 2 instead of 5 over 2. So I made a stupid mistake there. But yeah, so I would have only got 1 mark there. So luckily it's only 2 marks. Yeah, that's a bit annoying. So please check your powers. Yeah, check your powers. I want to move on to question 4. I'll see you in a bit.